Hello and welcome to day 4 of the How to Get Started with Solana Development in 2026 series. Today we're gonna talk about PDAs and CPIs and signatures. And we're gonna learn how to manually call an instruction. Understanding those concepts is essential for becoming a Solana developer. And they are very specific to Solana, so it's probably not something that you've come across so far. And that's why this is probably the most important video in this series, so do watch it carefully. Or don't. I mean, who am I? That's right, not your mom. So let's get started. Okay, we are going to build on top of what we developed yesterday. So once again, do make sure that you watched yesterday's video first. Essentially, we built the first quick little anchor program that can store some state in an account. We are storing the mood of the program or whatever. And we have 3 instructions, one to initialize the account, one to set the mood, one to get the mood. Okay, now, one very important thing to understand about Solana programs is that they are public. I've already mentioned Solana is a public blockchain. Everybody can read the state, and also everybody can call the programs. Just because you deployed the program does not mean that you're the only one who's able to call the program. You probably also want others to be able to call the program such that everybody can interact with it. But then maybe you don't want everybody to be able to do everything with the program. So for instance, in our example, setting the mood, maybe you don't want everybody to be able to do this. And right now, everybody is able to do this. So for instance, me as a hacker or whatever, I could write myself a script to call this program. This is what we did in the video 2 days ago, where we created a memo and a transfer sol instruction. This time, I'm gonna manually create an instruction because we've already learned what an instruction needs. Remember, it's just the program we want to call, the accounts, and the data. As we see here, the program address, well, I know that. I just need to know where that program got deployed. And also that is public information if we find one of those transactions that we want to emulate. So for instance, this was our program. This was the program that we wanted to call. So I'm just gonna say, hey, take this. And then all of the transactions, that stuff is also public. And then we just need to find a transaction that does the thing that we want to do, like set mood. And I can basically copy this instruction. Again, the program I already know. And then I see it just takes one account. I'll just copy that and provide that as an account with this address here. And then we need to provide a role, and the role is writable, so I'll just copy that as well. And then I can also copy the data. I don't need to understand what that is. I can just copy it and put it in an instruction myself. So the data will be a get base 16 codec encode this. Voila. So like this, it will do the same thing as this instruction, and either through trial and error or through educated guessing, I'm gonna change that 3 to a 0 to mess with the mood a bit, because we did learn the first 8 bytes are for the discriminator, so this will be the only parameter for the function. And like this, anybody, for instance this Andy guy, can call that program. Voila, we got a transaction, and look at this, we are able to send a transaction. It is successful. This guy called it with the state account and our program, and he was able to set the mood to sad. That's quite sad for our program now, because the program doesn't want everyone to be able to change the mood. That's really sad. So we gotta change something in our program. And what we will need is an authority. An authority is basically an account that is authorized to do something. So for instance, in this case, authorized to change the state, in this case, the mood of our account. So back to our program, we will somehow need to remember who that authority is. And an authority will be an account, because we said everything is an account. Because otherwise we would need to do, I don't know, username and password, but that's not how we do things around here. We let the account have the authority so that we can say this account that is creating this transaction, are they authorized or not? And how do we distinguish accounts, like what's the unique identifier of an account? That's right, the account address. So all we need to save is the account address. So we can say pub authority, and here I would put the address, except we're still working in an old version of Anchor, so it's called a pub key. Why am I still working with the old version of Anchor? Sorry. In the future, this will be called address. But in our case, it is a pub key as well, because we want to store the pub key or the address of the account that is authorized to change the mood. Now, obviously, that account here doesn't have an authority. I would save the authority when we initialize the account. So I would put that user here. We called it the user who's calling this. I will make the user the authority. Authority for the account will be this guy. Okay. So into my state account in the authority field, I will just write the key of the user. That's all I'm gonna do. And then every new account that we create will also have an authority. And what we then will need to do is to also check the authority. So we need to make sure that when we're setting the mood, that we first of all also provide the account that is authorized to do so. So we would do an authority here. And like the user, we would make it a signer so that this account is required to sign as well. We'll get there in a second. Now I can either do it up here and make sure that my context authority key is the same one as what is in the state account written under authority. And if that's not the case, error incorrect authority, for instance. Anchor has a shortcut way of writing this since it's used a lot. I can say here this account has one and say authority. So then it checks that the state.authority is also the authority in here. This one line does the same thing as this up here, essentially. So I don't need this, but this might be easier to understand for you. And like that, we protected our set mood that only the correct authority can do that. Let me prove that to you really quick. Let's anchor build and anchor deploy. Meanwhile, we update our test because we will need a new state account again. We don't need this number anymore. And we will initialize it with those accounts. Remember here, automatically the user is put in as our address. Oh, we still have invalid instruction data. Let's make it happy. Oh, and we can also skip deploy. There we go. All of those three things succeeded. The first one initialized this account. That's the state account, the new one now, the 9x. It was initialized with this authority. And so if we now provide this authority, then we can set the new mood. But what we cannot do anymore is try and set the mood for this account with a different authority or with an incorrect authority. This will fail us with caused by account authority. First of all, we didn't even provide enough account keys because this now requires a second account, which we can put that in. I'm just gonna say, hey, yeah, I mean that's me. Here, I am, take that account. But even then, it will fail with the state account. Constraint has one. That's the thing that we wrote here, the has one. It requires the correct authority because the thing we provided is not what it expected. That's the wrong authority. So that's why the program will not let this instruction pass. So the transaction is failing here. And we've learned that that reverts the state as if nothing had happened because that account isn't authorized. Okay, now you might think, hey, I can get around that. I'm just gonna provide the correct account here. But no, what's gonna happen then is we're gonna fail with account not a signer. The given account did not sign because this account, even though we can provide it in the list of accounts, we cannot produce a signature for this account if we don't have the private key. And here in this scenario, we don't have the private key for this one. We just have the private key for this address, not for this one. And that check happens because we said this needs to be a signer. If we were like, oh, this can be any account, or even specifically a system account is an account that is owned by the system program. We learned yesterday that every account has an owner, and the default owner is the system program. Every regular wallet account, also this one, is owned by the system program. I could say it's okay if that's just a system account. If I build and deploy this, then all of a sudden this here should work. All of a sudden this account is very sad because that shouldn't happen. And what was the problem here? The program didn't check for the signer. So a signer, and this is important to understand, really doesn't mean much until the program checks for it. Remember, every transaction has this list of accounts, and in this list, every account is flagged either as writable or not writable, and as signer or not a signer. The writable is important mainly for execution, so that we can parallelize that thing. Programs don't usually need to check whether or not that account is writable. They need to say, hey, I want this to be writable, but then if it's not provided writable, then the runtime will fail it, so that's fine. However, the runtime doesn't really do anything with signers, with the exception of the fee payer, because there needs to be one account that is paying the transaction fee. That needs to be a signer as well, but that's the only signer that Solana is checking. Everything else, every other signer, the programs need to check. The programs do something with it. Otherwise, it's not particularly relevant to the transaction whether or not that account is a signer or not. Solana, or the runtime, also checks that the signature is then actually present. It does do the sig verify. So if the program is told, hey, this account is a signer, then we know that a signature was presented for this account. And that's why also for every signature we pay a little more in transaction fee. But it's all useless until the programs check for it. So that's one of the classic mistakes that you can do, is forgetting a signer check. This authority shouldn't just be an account, it needs to be a signer. Only then can we guarantee that whoever's providing this account also has the private key for this specific account, and therefore we know, oh, it's them. They are authorized to actually change the state. Because having the private key, remember, is how we prove that it is our account. That's why it's also dangerous if that key gets leaked, because then whoever has the key has the authority. So yeah, that's the concept of an authority, and that's why we need signers. A transaction can have several signers. It doesn't need to be just this first address. So if I had access to the private key of Andy's wallet, which, let's say I'm a hacker and I somehow got access to Andy's key pair, which just so happens to live at my config ID JSON. And that, by the way, is the same one here. Again, that should still be the same as we had before. Let me just quickly make sure that our anchor program is deployed in this version now again, with actually checking for the signer. And yes, like this, we again get the account not a signer error here. So what we need to do is actually make this signer. I don't actually need to write to it. I can do a read-only signer. Then I need to provide the key pair. So I need to add signers to instruction. I'm gonna add the Andy's key pair to my instruction, and then I put this in here. Then that should work. Look at that. Now we have a transaction with two signers. Once this Andy guy signed as the fee payer, and once this wallet account signed as well, because the program instruction required this account to be a signer. And now we once again have the authority to set the mood. And I can also set the mood to something else like bored. There we go. And now we're bored. Easy. Because it's too easy, right? It's too easy. Yeah. Point is, we can have several signers in a transaction. We just need to have the private key for that public key to actually be able to provide that signature for this transaction. Okay, that's the one way to sign. The regular way to sign with the private key. Remember this, because we are gonna explore an alternative. But first, I want to talk about cross-program invocations. Another essential topic for Solana development, and we have already seen that before. Here, for instance, a cross-program invocation is when one program calls another program. And we have already seen this before. In our initialize, our program was calling the system program. So this is a CPI. We have inner instructions. The system program is being invoked by our anchor program to do the create account instruction. And stuff like that is what makes Solana programs so composable, because every program can interact with every other program. So once a program provided some functionality, other programs can build on top of that. And that's actually used a lot. So much so that we're increasing the limits for how many CPIs we can do. Anyway, so this CPI here to the create account is hidden by Anchor with this init constraint here. Anchor just hides that functionality. But let's build our own program that does a CPI. So let's do Anchor init again with Anchor's CPI. Again, I'm not being creative here. I'm gonna call it Anchor CPI. And then I'm gonna open this. And while we're here, I'm gonna show you a trick, because that program ID is not God-given. If you're not happy with the address that your program will get deployed to, that just lives in here in this key pair JSON. And that's the same thing that we created with our Solana keygen. So I could once again just say Solana keygen grind and get myself an address that starts with CPI program, for instance. CPIP. There we go. My CPI program. And now I just copy this to my target deploy key pair, and then it will be deployed to this address. So I can put that here as well as in the anchor toml, and I'll be fine. Change that to definite. Quick little trick. Now you know. Okay, what does this program do? Let's just let it call the other program. Literally a do CPI, or I don't know, that's better. Change mood, or even better, make us happy, whatever. So this basically just should set the mood to happy accounts. I might recycle this and call it change mood accounts. So what do we need here? Well, first of all, we're gonna need the program to call. Just gonna be a program. It's a given program. Let me see if I can import that. Okay, let's see. In the cargo toml, how about I add dependencies to the anchor program. Here it's spelled like this. And I'm gonna get that from what we did yesterday in day 3. And I want CPI as features. Let's see if that does. Nah, that doesn't work. Oh, oops, wrong cargo toml. Ah, in the program there. Yeah. That makes more sense. Here we go. No such file or directory. It is with a dash. Maybe you need the program /programs/ anchor program. Maybe that's what you need. There we go. That looks better now. Okay, with that set up, we can now use our anchor program. See, that's our program because I imported it from here. And that has the 3 instructions and also somewhere have its ID. I don't see that. Why don't I get the ID from this? Okay, I don't really know how I get that in there correctly. So I'm just gonna use a regular account info here and be like, I will check this manually, or I don't check this at all. Then what else do we need? The authority. Also that I just take as an account info and be like, whatever the user provides, we just put that through. And that should actually be enough for us to then invoke that program. So we just need an instruction within our program now. So inside our program, we build the instruction that is then executed through CPI. And if you manage to import your other program, I'm gonna make it easy for myself. I can import this set mood and I can just say set mood, which takes the context and the new mood. And we will look at how we can do that the manual way with invoking or invoked signed in 2 days when we write a regular Rust program and not with Anchor. But with Anchor, I can just import my other program and then call it like this. So the new mood, I say 1 for happy, and the context, let's see, would need to be set mood accounts. Set mood accounts. This guy needs the authority and the state. Oh yeah, I forgot. We need the state account here from the context accounts state, and then the authority, same thing, from context accounts authority to account info, that we then put in a context. So we need a CPI context, and here we say what program we call. That would be my context accounts program. The accounts, those are my CPI accounts. Okay, and then this CPI context is what I call the set moods with. Let's see if that actually does what I want it to do. And for that we need to call this program, and I'm just again gonna do that through tests. Make me happy. Anchor build. Wait, does it build? Oh no, it does not build. Shit. Oh, hold on. Oh, yeah, we have mismatched types. Anchor does already want me to check that here. Okay, let's see if I can get that to work. So you want the state and the authority to be a signer. Well, that makes sense. And the state to be an account of type mood account, which I can also import from the other program. Would that help? Maybe you don't want the account info? Oh, you don't want the account info here then. Oh wait, that's not even the CPI. Are we not doing the CPI stuff? I'm missing the package. Hold on. So I'm missing the feature for CPI. But why do I not get this? Yeah, you have the regular context, but I want to have the CPI context. Feature CPI. Did I misspell that? Nope, I did not misspell that. Ooh, now I have more. Where does that come from? How? What? Now I also have my ID and stuff. Well, that's great. Yeah, and I have the CPI. What did I change? I have no idea. Anyway, so I need the CPI set mood. That's better. Forget that. And that should also mean that I could have my program, anchor program. Perfect. So like this, I can say down here, make it an actual program of type anchor program. Now I found the way to do the exports correctly. That's great. And here the accounts, set mood accounts. There we go. And you now need account infos. There we go. I'll just make that an account info again. Okay. So I was hacking around here a bit, and it's not super important that you understand all of this right now. This is anchor peculiarities. What I want you to get from this is that we can call a different program from our program. In our case, we call the one program that we developed from this other program that we developed now. So from our CPI program, we call the other program. That's the idea. Okay, does that build now? Yes, that finally builds. Okay, or not. Safety check fails. Where? The authority? Wait, what do you need to check? Okay, you don't like a custom attribute? Well, I can use a mood account. Does that help? Yeah. Okay, so it wanted a specific account here. Then I give you the specific account. Again, anchor. Anchor being anchor. So now for the test, we have this make us happy that will just not take any input, but we will provide the right accounts here, otherwise this will not work. And we need the authority and the state. The program, it knows which program to call, but the authority, well, that's also gonna be my user, that's fine. But then the state, at least I need to put the account for the state, which was that the 9x. Here, take this. Take this. Okay, and then we just anchor deploy this, a program to make us happy. Then let's test. And oh no, make us happy. Writable privilege escalated. Oh, yep, that's my bad. Because also as a developer, I am responsible that I request. Well, am I though? Well, in Anchor, I'm responsible for it. When we're running this, we're not providing the accounts as writable. That's the problem. But we're not providing them as writable because our Anchor program doesn't request them as writable. So the program we don't write to, the authority we don't write to, but the state we do write to, and that's Anchor specific. Anchor wants it to indicate that this is writable. Then we automatically run this as writable as well. And now, oh, that's a nice signature. in 777 milliseconds. Now we can look at this. 1T1. We send a transaction with those accounts. See, both of the programs are in the list of accounts. Our Anchor CPI program tries to make us happy by doing a CPI, so by calling another program, calling the Anchor program with a set mood with those accounts and this data, and voila, we see it here, the program got invoked, and then the set mood instruction is called. And we're now happy. We're now happy, finally. Yeah, Anchor is sometimes a bit weird, but you don't need to worry about that. Again, the main thing I want you to take away from this is that we can call another program from within our program. That's the important thing. That's already enough for today, if you get this. Because the real topic of today are still authorities. And so far, we had the authority being a user wallet, where if you have the private key, you can sign for it and therefore you prove that you have authority. Now, there is a different way how Solana can do authorities for when a program should be an authority. So for instance, if we in this program wanted to prove that the mood is set from our program, and the other program, this one, could then check that this authority is that other program. And that is done through PDAs. Another core element of Solana development that you need to understand. Program derived addresses. So I'm gonna leave this program the very same that we have it. The authority needs to be a signer to be able to set the mood then. But what we're gonna do now in this program is that we're gonna set it up in a way that the program itself will be the authority, or rather a PDA of the program, and therefore the program will be able to sign without even having a private key itself. Because obviously a program can't have a private key because programs are public and everybody would just be able to read that. So there's this concept of PDAs, and I'm gonna make my attempt of explaining that to you, such that we can get ourselves excited. So for that we use exciting accounts. So we're gonna almost do the same thing as before, but first we gotta set us up for excitement or whatever. I'm just gonna call it set us up. I could also call this initialize. What this is gonna do is it's gonna initialize a mood account here. So we're gonna CPI into the initialize from the program. And once again, we will use the program. This time I'm not gonna let the user give me the account to be the authority, but I'm gonna create myself a PDA. So it's gonna be an account of form, I don't know, my PDA. I'll call it a PDA account, which doesn't even need to store anything. I could put data into here, or fun fact, I could also not even create the account, but in order not to have to work with an unchecked account here and Anchor annoy me, I'm just gonna say, no, we actually create that account as well. We init this, so therefore we need a payer again. Oh, and for that I need to have the payer, and this will again need to be a signer who is writable as well. And then I will again also need the system program, because we will need to also do a CPI to the system program to create that account. So system program payer is payer and space. Literally, I'm just creating an empty account. I'm not using the state of this account. I'm using the property of being able to sign with this account. So as I said, I wouldn't even need to create it, but I'm gonna. So this is gonna be my authority PDA. Actually, I'm gonna call it authority PDA, such that you understand that this is gonna be a PDA. So the state account is gonna be a mutable account for mood account, but this is just gonna get initialized in the next program. So I'm afraid I can't check it for mood account here. I'm just gonna say account info and say check created in CPI, such that it doesn't complain here that I don't provide the type. Okay, so I have the program, we have this PDA. Now, what's special about a PDA? What is a PDA really? Program derived address. It's not one of those accounts where there's a private key for it and the account address is the public key. That's one type of account. The other type of account is PDAs, where there is no private key. PDAs specifically are designed that there is no private key, and half of the addresses roughly have no private key. This is just how it is. We don't need to discuss why. Elliptic curve cryptography, some are on curve, some are not so important. But what is important is to understand how the PDA is created. And the PDA is created through seeds. Basically just a list of bytes where we say those are the seeds for the PDA. And a PDA is created for a program. So with those seeds and the program, we can get the PDA. And if we provide the same seeds and the same program, we get the same PDA. That's deterministic. So in order to create a PDA with anchor, we just say seeds and then we provide a list of seeds. For instance, we can just use the string authority. Then I have this one PDA for this program. So in every setup, I use the same authority. I will also say bump here. A bump is just used that we reach this property of there not being a private key. So we need to push the address off the curve, and that's done with a bump. I do have a more technical deep dive on PDAs. You can watch that up there. For now, it's not so important. I do want you to understand that we need seeds. Like here we have this bunch of bytes here, and we derive it for our program. So for this program, then we get this PDA, and Anchor does that automatically for us, and it will know what the address is here. And then in the actual setup, I can do the functionality. So I'm gonna do the same thing as here pretty much, except now I'm gonna do initialize accounts, which need the state, the user, and the system program. They are still called it the user, but that's the authority for us. And here I will put my authority PDA. And then what else does it need? The system program. I also have that in my context accounts system program. I'll just give you that as account info. And then I'm gonna call that other program and do the initialize with that context. There we go. That should set us up. Let's see if that builds. It does. Amazing. So to our tests. Set us up. What do we need here now? The pair, well, that's just gonna be my wallet, that's fine. And the state, hold on. The state is the state account. Oh yeah, we're creating a new state account. Just gonna do that, but I will need to add it as a signer as well. We're creating a new account essentially. Let's see if that works. Nope, unsigner. Oh, did I not make the state a signer? Ha, okay, right. Then I just make this a signer here. Better. I need to make it a signer. Yeah, sure, why not? Then I don't need the check either. Perfect. Ha! Okay, good. No, that's good. That's good. Cross-program invocation with unauthorized signer or writable account. Now what's happening here? We are trying to initialize and have our authority PDA as the user. Remember, last time the user, when we were doing this, the user was a regular signer. So this account here is expected to be a signer. But here, this PDA, this address, there is no private key for that, so I cannot sign for this. This is just a random address. Not really random, very deterministic and specific. But here, this is not a signer. And now comes the trick. When we're doing a CPI, we're not doing a regular CPI. Later we will see it's not a regular invoke, it's an invoke signed. So this context here, we don't do a new CPI context, we do a new with signer. And then we can provide the program and the accounts and signer seeds. So this is where it gets interesting, because here basically the program proves that it is actually the one that is doing the CPI. So that it is actually the program that this PDA was created for. Because again, we created it with those seeds for our program. And now here we need to provide those seeds one more time to prove that we are that program, essentially. So the way this is written is a bit weird with a slice of bytes. But the first one is because there could be more signers. For now, we just have this one. So we just do one. And then this one signer does have a list of seeds, namely this thing plus the bump. So I'll have to put this thing and the bump, which I can get from the context bumps authority PDA. Temporary value dropped. Well, okay, fine. Let's store it then. Let's let the signer seeds be this. Okay, maybe I just need to type this as well then. Slice off, slice off, slice off you it. Yeah, then you're happy. Okay, fine. Cool. So with those signer seeds, it looks ugly. Don't worry about it. The thing is, it just needs to be the same as I have here. That's all. And with that, I then basically make this account, the authority PDA, a signer. That's the magic of it. Let's see if that actually works. And it doesn't. Damn it. We are getting a form must not carry data. I think we're putting the wrong account still somewhere. When we do the setup, the state is this. Hold on. When we're creating the account for the state, the account already exists. Why does this state account already have data? Are we putting in the wrong thing here? Can you skip preflight for a second so I can look at this? What's happening here? We are failing in our CPI because the initialize calls the create account for the from address is weird. Oh, I'm trying to fund it from the PDA, which doesn't work. I see. This one is our PDA. The new address that we're creating here, this is our PDA. That's the one that we're signing with. So it becomes the user really for our anchor program. Here it becomes the user. But then that anchor program thinks it can just debit that user with the system program, and the system program is like, whoa, that's a PDA, that's not a user wallet. And the real problem here is the system program at that point isn't even the owner anymore of that account. It's now my program. So that's why this doesn't work. So I will have to change that program a bit, sadly, because I can't have that user be the authority and the payer at the same time. So we're gonna split that real quick. User is not a good name for this anyway. I called it user just that you understand what that is. That is the user account, which it was yesterday. Today it's not anymore. Today this is for one a payer and for two an authority. We're just gonna split it. Both of them will need to sign. One pays for this new account, the payer. So this guy will pay for that account, for the state. And the authority will be the one that we write into here when we initialize the state. They can be the same, they don't have to be the same. So now when we test here, that should actually still all work the exact same. Yep, there we go. Just that in the initialize, we now provide the payer and the authority as separate accounts. And then the state account that we create. And with that slight change here, now we also need to update this. It's not the user anymore, but we need the authority and the payer. I'm gonna also use the payer that's signed here, which is an actual system account where the system program actually accepts it to pay for an account. Okay, that was maybe a bit more complicated than I wanted to have here for this example. If you don't fully get it, that's fine. Okay, now this works. Great. Look, that's the new state account. That's the PDA that we actually, I'm gonna name those. That's gonna be that's the authority PDA. That's the state account with PDA authority. Ha! That works exactly in 32. It's a bit long, but that's my description for this account. And that's my caller program. And that's my callee program. Great. So for the instructions, at first, our anchor CPI program, so the caller program is being called. Then the PDA is created. Again, this step we could skip. We don't really need that account to have any state for being able to sign with a PDA. I just created it anyway, just so we have it, basically. And then we call the initialize of the other program, which then also creates the state account through a CPI to the system program. So in here we see the depth of the invoke. We're on top level, then we invoke system program, then we come back to top level, then we invoke the other program. This one invokes the system program, so that's level 3 then. Yeah. So once again, we see that Solana programs can call other Solana programs. And in this case, our Solana program also provided an account as a signer that wasn't a signer in the transaction. This account here, the authority PDA, is not a signer. The other one was, so we can create that account. But this one is not a signer. On transaction level, it is not a signer. However, we could still put it in here as the authority to have it here as a signer. Here, that program accepts it as a signer, even though it's not a signer in the transaction, but it is a PDA and the other program signed for it through the CPI. It didn't invoke signed. So by providing those seeds, it is as if that account provided a signature, but it didn't. It was the program signing for the PDA. And that's such an essential concept that if you really get this, you unlock how you really write Solana programs well, because those PDAs are quite powerful. PDAs allow you to do pretty cool things. And that's how we can have programs be the authority for something as well. Because through PDAs, we can sign. Okay, now we also said that those PDAs, if we provide the same seeds, then we get the same PDA. That is also the reason why I cannot do this a second time now. If I try to do this a second time, I'm failing, because when I'm trying to create this account, that account already exists. It's already in use. Why? Because we just earlier did that with the same seeds we set in it, so the account was created for this PDA. So now for it to work, I need to remove this, that this account is not created anymore, or change the seeds. And that's also exactly one of the nice use cases of PDAs. If there should only be one account per program, then I just use constant seeds like this, like the authority or say the treasury or whatever, where there's always just one per program. Then I can use a PDA like this. That would have been also a great idea in yesterday's program, when for the state account, we would just like to have one state account for the entire program. Then we could use a PDA like this. So here we could make the state account a PDA now by providing seeds like state and bump. Then we will just have one state account for the entire program, and we would need, of course, to also do that down here. Then when we set the mood for the account, we could do the same thing, force it to just use this one, and also for the get. This would be one way how we could ensure that there's just one state account for the entire program. Then it doesn't accept any other accounts than this one state account. But if we wanted to have one state per user, or in other words, in this case, it would be one state per authority or one state per payer, we could say everyone who pays can have one state account, but that's not so nice because the pay is just where the funds come from. It would be more sense to bind it to the authority, because that's the one who is actually in control of the state account then. So I can say I allow one state account per authority by adding the authority as seeds to my PDA. How does that work? Here I say authority key as ref. Yep, that works. So this way I will take the 32 bytes which make up the address of the authority, again, can be the pub key or the PDA, so the program derived address. It's the 32 bytes that make the authority that I will add after the state literal. And so whenever the authority is the same, those bytes will be the same. Therefore, the entire PDA for this state account will be the same. That's how we can bind this account to one account per authority. So I would do this here as well as here and here. But then for that to work down there, I would also need to provide the authority down here now, which wouldn't need to be a signer in that case. So actually for reading, I could either add both of that, or I say anybody can read from any account. Then you manually need to put in the account. We don't let Anchor derive it automatically. That's the more efficient way to do it anyway. So I just let everybody read all of the accounts. That's fine. I still don't want to have a signer for that. But for setting, I do definitely want to have that signer. And I use that state account as a PDA. Let's quickly showcase this as well. And Anchor deploy. Now we got to update our tests here, because now we don't need to provide the state anymore, because that's not a new key pair. We don't need key pairs anymore, because the state will be automatically derived because we know the seeds and we know the authority, we know that literal. That's all in the IDL. Remember that interface definition of our program. The state account is a PDA with the following seeds, those few bytes plus the authority. So we don't need to define that here anymore. And we also don't need to sign with this anymore. Same here. We don't need to provide the state anymore. Here, we still need to provide the state account. We would need to derive it manually. We would just have to put in the address for the account, which we will get when we look at the PDA. You can also derive it. There's a function for that, but I don't want to do it in the old Web3.js. So this initialize we can now only do once, because once the PDA is created, and this is the address of our PDA with the mood, that's the address now. If we now try to initialize it again, obviously that's not going to work because we've already created that account, but setting the mood again still works. That's our PDA for the state. We set the mood to happy, great, and then also reading the mood. For reading the mood, I don't even need to sign for it. I just need to know which account it is, and it will return our happy mood. So that's the program by itself. Now I can also update my calling program to work with this. So now let's set us up the account for this authority, which is my program's authority. And the state here, now this doesn't need to be a signer anymore, but this will be an account with the following seeds. This would derive a PDA for our program. We will need to say seeds program if I want to derive for another program, and that will be this program that I derive it for. And that will be my authority PDA key that I put in here. Like this, it should use the correct PDA here automatically. Let's test that. No. Yeah, you're again unhappy because I use an account info here. There we go. Trust me, bro. I know what I'm doing. It doesn't like me to use account info, but this is an uninitialized account that the other program will initialize. So I'm just gonna say, trust me, bro. So let's quickly update the setup. We don't need the state anymore. We don't need a key pair, and we don't need the state account here anymore. We don't need to provide the signer. It's just the setup. It's all automatically done with the PDAs. It knows all of the accounts that it needs. Again, Anchor is magic. So now I can just test this, and that doesn't work because that already exists. Oh yeah, of course. We said our account already exists. So ideally, we would put a separate initialize instruction for our authority if we would really need to create that account. We could also just say we don't even need that. We could make that an account info to any account. Again, if we're just signing, we don't need any state on that account. But yeah, let's not create it again and redeploy this. Oh, then we have writable privilege escalated because I stole the init, which made this authority writable. Wait, why do I need that authority to be writable though? Unauthorized signer or writable account. That account's writable. So basically our authority PDA is not writable anymore when you expect it to be writable. Oh yeah, that authority doesn't actually need to be writable. The payer needed to be writable because we remove Lamberts from there, but the authority doesn't need to be writable. I could also fix it by making it writable here again, but I don't need to, because that doesn't need to be, I don't need to write to that account. So don't unnecessarily make accounts writable if they don't need to be. It's also a good tip in general. So let me quickly rerun that. Okay, and with the other program being redeployed, now that works. I can create an account, this one now. That's the state PDA of the first anchor program for my authority. So for this authority that we initialized here. So that's the authority, that's the account that was created. And now let's finish this up by getting us excited, where we do another CPI to the set mood. We set the mood to 3, I think was excited. 0, 1, 2, 3, yes. And we now just need the right accounts. The other program, the anchor program, that's correct. The authority, we now use my authority PDA again. So not a signer, but a regular account with these seeds. And the state account will also be now a derived PDA like this. Same we had here. And now I just need to update to PDA here. And then we can run the get us excited. Again, don't need to provide anything. We don't need no accounts. We can just say get excited and it knows what to do. That's literally all. And I just run test. Oh, of course, again, unauthorized signer or writable account. Signer privilege escalated. It is not a signer. Once again, the authority PDA is not a signer. This one, the authority PDA here is not a signer. For it to be a signer, we need to again provide the signer seeds, the same ones, and create this with signer and also add the signer seeds here. Then that should now work. So again, we are signing as the program for this PDA. Ha! There we go. That's what's happening. We are doing a CPI from our program into the other program, where we call the set mood with our authority PDA as a signer to that program. To that program, it looks like this is a regular signer. We can write to this PDA, that is the state account, and get us excited. Set the mood to excited. So to recap, there are two main things why PDAs are very useful. One of which is to be able to make that account a signer when we do a CPI. So in the program that's being called, it looks like this account was signed for, and there we can't really tell anymore if it was signed with the private key or if it was a PDA and another program did the CPI. Could be both. That's the one thing why we need PDAs, for programs to sign. And the other reason why we like PDAs is to do stuff like this, where we actually do create an account and not just use it to be able to sign for it, but we do create an account like the mood account here, but we use those seeds to somehow limit how many of those accounts can be created, either one per program or one per user, or one per user per something else. One per user per other program, for instance, or one per user per other account. For instance, if every state account now had sub accounts, then we could do those sub accounts in PDAs for literal and then the authority and then the mood account or something like that. Put the mood account as a seed here. So usually when you create an account for the program, in most cases, it's good practice to create it as a PDA, because then you can define the seeds for it, which then also allows you to sign for that account if that's relevant. But also if you don't need to sign for those accounts, it's just good practice because you don't need to create a key pair to then create this one signature that needs to be verified in that transaction just for the system program to create the account. It's just easier if we do that with a PDA like this, and if we initialize it like this, then it looks to the system program as if we have provided a signature for that account, even though we didn't. We just did the CPI with that PDA and invoked it signed. So that's just good practice when creating program accounts to do them with PDAs. It doesn't always work. In some cases, you do want the user to keep control of that account or let the user create it at a specific address, but then they need to provide the key pair where they've grinded that address or whatever. That's also fine. But yeah, the cool thing about PDAs is that we can use them in such a hash map kind of a fashion for creating our accounts, and that we can sign for them when we call another program through CPI. And with that, I think it's enough for today. We did learn a lot. I still need to give you homework though. So one part of your homework could be to change your program to use PDAs and play around a bit with that. Or if you're up for a challenge, you know my program ID, right? And this program is deployed to DevNet. It's public. So my challenge for you is, can you call this program and create yourself your own mood account for your authority? I had it quite simple here because Anchor does that all automatically for me. So yeah, essentially that's a challenge of how can you build an instruction like that yourself with calling a PDA. And don't worry if you don't manage to do that. I want you to try, but if you don't manage, that's gonna be something that we're gonna have a look at tomorrow when we're gonna talk about tokens. And we're gonna deepen our understanding about PDAs some more. Okay, but I would say that's good enough for day 4. Thank you for watching. We did learn a lot. We finally went over PDAs and CPIs. We had a look at how to manually call instructions. We saw what PDAs are good for. We hopefully now understand the concepts of authorities and why we require signatures for some accounts and what that really helps us in the program. All of that is just essential for becoming a Solana developer. And if that's your goal, I'll see you back here tomorrow for day 5 of this series. Do make sure that you give me a like if you enjoy this. Subscribe if you haven't done that already. Might as well tell you. And I'll be back here with you tomorrow. Till then, good night. Sleep well. Tomorrow we finally talk about tokens. Another essential thing. You gotta understand how tokens work. Good that there will be a video for that tomorrow.